Well, thanks everyone. I'm so glad that it's already what's the time now? After 4. We still have so many people over here for the talk. Thanks for coming through. Cool. How's everybody? Can I get a yay? Yay. Nah, I can't hear. I've got problems with my ears, man. Come on. Okay, can I get a yay? Yay. Can I get a yay? Yay. Cool. Okay. I'm pumped up. I had I don't know how many coffee. Okay, so let's get kicking. Okay, cool. I'm gonna show today how to build a scaled down version of a self-driving car. Sounds very simple, it's just like, hey, you know what, it's just a car, it's just a miniature version, okay? We can build it. Of course we can build it. But the amount of learning, the amount of time, the amount of effort that goes through this thing, it's crazy. So I'm glad that I'm getting a chance and opportunity, and thanks to the DevConf organizers for giving me a chance to share this with you. I hope you guys enjoy it. Cool. Okay, how a normal person generally tells a story. Of course, it's right in front of you. They start at a point and they end at somewhere else. I'm not normal, come on. Okay, I'm gonna tell you the story this way. Okay, I'll give you a minute to just go through it. It's a bit complex. And if you guys don't mind, I'm gonna be walking around, strolling around a little bit. Too much of caffeine, just need to calm it down. In my zen. Cool. So of course I'll jump around a lot. There's a lot of prologue to complete, there's a lot of context to be given, a lot of if and thens, a lot of things that I've tried that didn't work properly, a lot of things that I did try that I wasn't expecting to work properly, and I was like, okay, didn't expect that. So let's see. Who am I? No, I'm not Spider-Man, sorry. No, I'm not even Batman. Sorry, I don't know what happened there. Am I a programmer? Am I a developer? Am I a coder? I don't know. I think I see myself as a technology enthusiast. I love technology. Always feel and think that there are problems, and if there's existence of problem, there has to be a solution, and technology is a means of solving it. It doesn't matter what is it. There is always a way of solving it. Yeah, literally, talk tech to me anytime. Literally anytime, seriously. A lot of guys are over here from DVT, so they can tell you. Sometimes they're like, Saurabh, calm down, enough, please. Just for a minute. I was like, no, but you haven't heard about this. You need to listen about this one, okay? I love coffee. Thanks for the sponsors for the coffee. It's amazing. Trying out a new one, caramel, I think. My current role is that I'm a practice lead at DVT for our Java division. And yeah, I'm glad to be here. Today's agenda, I'm gonna make it very formal. I'm gonna go point by point. Project, hardware, software, what's the future, okay? Get everyone's approval and stuff, like you have to sign and tell me how did you like it, you have to rate me, okay? Nah, it's not gonna be like that. I'm gonna do a lot of this. So just bear with me and hang around, okay? Cool. So what is this project really about, Oh, sorry, love for cars, of course, come on, Looks awesome, eh? There are so many brands that you can see that everyone knows about, and then there are so many brands and certain set of companies that have come through that no one knows about, right? Why is this such a jumbled picture? Is that because it's not just about a car manufacturing company anymore. It's about mobility. It's about ease of doing things. It's about ease of moving from point A to point B. Every single company that you can see on the slides over here, and many more, I'm sure I missed a couple of them, maybe some that I don't like. Each of them are doing something in terms of autonomous vehicles. Could it be cars? Could it be bikes? Could it be bicycles? I don't know, maybe some roller skaters also would be cool. So a lot of things are happening around right now, world around. Companies are partnering with each other, they're busy building awesome stuff in terms of autonomous and autonomy. But a lot of times people get confused about what is full autonomy, right? And what is semi-autonomy. I know the Q&A is gonna happen later on, but everyone is staring at me and I'm feeling very uncomfortable suddenly. Who over here, just quickly, difference between autonomy and semi-autonomy? Anybody, please. Got 10 seconds.
Full autonomy is it some form of intelligence. Semi-autonomy is like sort of if this happens, just do that. It's like more simplistic.
So I'm sure like in semi-autonomy, the car is just going to say that, hey, you know what, look, I don't know what happened over here. Here's the steering. Deal with it. Oh, sorry. Oh, okay. So of course, like, yeah, full autonomy means everything the car does for you, right? You just sit over there, relax, chill, sort it out. Semi-autonomy, you have to handle and deal with certain things. All these companies are doing some great stuff right now, starting from machine learning things to busy building brilliant AI and machine learning algorithms that does it for you. So they're doing a lot of crazy stuff, but I also want to do some crazy stuff, okay? So what do? Let's build a do-it-yourself self-driving car, right? Why? I like to stay hungry and stay foolish. I enjoy that. No, it's not about the bunny chows and stuff. I love that, yeah. Stay hungry because I want to always keep looking for something challenging, something exciting, something that truly drives me to say that, look, this is the next step, let's try something else, okay? Stay foolish because I want to try out new things that maybe others have tried, others haven't tried, but I haven't tried, right? So I need to give it a shot. And the worst that can happen is that either I'll succeed doing it or I will fail learning something out of it. And believe me, today's presentation is more about all the failures, all the dumb things, all the foolish things that I've done in order to learn something good. And I hope that maybe this can motivate others also to remain hungry and foolish. I hope so. Why I wanted to build a self-driving car? I wanted to learn about artificial intelligence, machine learning. I've been reading about it. There's always something new over the news. And then one day just like, okay, enough, man. Just want to write something, do something. Let's build something. I think I know enough. Oh boy. I was foolish. I didn't know actually anything. Okay, wanted a new challenge? Yes, I did get a new challenge. And it's cool. Come on. Look at this. It's awesome, eh? We'll have a closer look soon, okay? So, yeah. Moving on. Yeah, we named it MARVIN. MARVIN, KITT, FIREBIRD. Just a bit of a nostalgia from the 80s, if people remember Knight Rider. Yeah. Okay. Let's jump down straight into the hard parts. And believe me, these were the most difficult parts for me also. I'm not a RC hobbyist. I had rarely any idea about where to start. Started to go through all sort of open source documents, open source standards to say that, what do I do if I have to build a car? Like really, like a scaled down car, what should I do? Where do I start from? Okay. Found a lot of good blogs, informations, many other things around over the internet, and thanks to our awesome open source community for supporting and being there to provide that kind of information, I was blown away. I was like, wow, too much of information. So let's start simple, right? Let's not over-engineer it. Let's keep it simple, stupid, okay? Cool. Found out that there's a chassis that I can use of HSP 94186. There's a brushed motor and there's a brushless motor. Don't ask me what is it. I don't know. I'm being dead honest about it, okay? Went through a couple of hobby stores in Centurion, Pretoria, everywhere, contacted. They said that, look, if you want to start something, start with a, 1:16 scaled down version. This is a good car. It's small in size. It's not very big. You know what? You can maybe easily get parts. I was like, oh, cool, perfect. I'll do that. Hold on, out of stock. There was nothing available here in South Africa. So I started to contact everywhere and finally found out that someone from Japan can actually send something over here. And I was like, let me check the cost. And the cost of FedEx was more than the actual price of the car. Jeez, okay. Let's leave it for later, okay? Let's jump into the actual cool part of things, the hardware part of things, and soon we'll jump into the software part of stuff. Some of the dimensions around was the height. Well, you can see the details over there. Yeah, some of the cool stuff about the car though. Shocks are quite cool, okay? I don't know if you can see the pointer there. The tracks and stuff are there, and then of course the bumpers. The bumpers did help. A lot of times I did a lot of dumb things where the Raspberry Pi crashed. The car just went. Wow. But believe me, dumb thing happens. And I did a lot of dumb things. Next thing is the Raspberry Pi, which is the brain of the car. A lot of times, a lot of my buddies, friends, colleagues, they asked, why don't you use Arduino and stuff? It's so cool, man. You know what? I was like, yeah, I'm a lazy developer. I want to do something smart and quick, right? Arduino is for pros who understands all these nice, good electronic stuffs and they love wiring and all those things. I don't. I just want to build intelligence into something quick, not dirty, but quick, and have it up and running over there, and then let it be the real brain power behind the car and do certain things. So decided to make use of the Pi 3 Model B. It's easily available over here. Two things that I really liked was it has got the Wi-Fi connectivity and of course the camera interface. We'll come to the camera interface soon. This was quite tricky, the servo motor driver. Didn't know that, again, not being a hobbyist, so didn't know that, had to make use of a servo motor driver in order to control the motor and the servos of a normal RC car. So start to go around and stuff. There are, I think, 7 different variations of this. So each time I go back to the hobby store, the guy's like, oh, again, you. Have you decided? I was like, oh, I don't know. I'm getting information from you. I'm going and reading about it, asking people about it, questions after questions. Then someone says that, hey, try a 16-pin, 16-channel servo motor driver. Got all the details and specs from some of the websites and stuff. And then again went back and I was like, but what does this pin do? What does that do? Because, I don't know, how am I supposed to connect this thing? So you have to gain and learn about all those things, right? Hit and trial, finally decided maybe this is the right one. And it was the right one. I'm glad. Now let's come to the I. The real reason why I was trying to build this thing was to actually see that through vision, can I teach a small machine just to do something? If my biology is not wrong, and I hope it's not, I think 90 to 92 or 95% of data that gets fed into our brains comes from our eyes, right? And the remaining senses might be giving some other feedbacks and other information into it. That's it. But just imagine how powerful our brain is to actually take that much of information, right? Just through vision and then process it rapidly in an amazing way. So I was like, okay, cool. I need to give an eye to the car. Perfect. Let's do it. Finding this part was very difficult. A lot of hobby stores and Raspberry Pi stores didn't have it. Had to wait for a long time. Finally got it. And this thing is extremely sensitive. Okay? It's not just like a normal lens and it's like, oh, you're not looking nice. Oh boy, what did I do? Oh shit, it's not working now. Okay, looks like I broke it. Long story short, I didn't break it. Because when I got it, the guy actually suggested me saying that, no, you have to use it properly, and he gave me all the instructions and everything else. I was like, perfect, cool, I'll just do that. Did a very, very stupid thing. This was one of them. To actually have a DC to DC voltage converter, thinking that I've got a battery in the RC car, why buy another one? Why waste money? I'm going to connect this thing directly to a voltage converter, pull the power from the battery, feed it straight to the Raspberry Pi, killing 2 birds with 1 stone. Yes. Dumb thing. Completely dumb thing. Why? The car has a nickel metal hydride battery. Performance sucks. Okay? It's not very strong. You charge it for an hour or 2, and the way you drive, and I was driving it like, yo, new toy, yes. 15 minutes, 20 minutes, gone. And I'm like, but I just charged it for 2 hours, man. Like, what the heck? It's a 1100 milliamp battery. Okay, at least should give me like, I don't know, half an hour? Come on. So the dumb thing that I did was, and a very, very bad idea was, using this voltage converter, thinking that this would be the best way to power the Pi and the motors and the servos together from one battery. I was trying to keep the car much more lightweight. Very, very dumb idea. It just looks cool on there right now. Does nothing. I had to disconnect it. Let's see now. Let's come to the car battery, right? As I said, it's a 1100 milliamp battery. Got 6 cells. It completely sucks, really. It's one of the worst batteries that you can use. Someone suggested to me saying that, why don't you make use of LiPo battery? And I was like, perfect, cool. Let's go find out. Found out which is the right size, price, everything. And then I see this warning sticker. I don't know if you guys can read everything over there. So it says over there, the electronic speed controller on this model is designed to operate with 7.2 volt and a range in terms of your milliamps with NIMH battery only. Operating beyond certain specifications and stuff with using incorrect battery power and stuff can damage this thing. So I was like, ah, come on. Not being a hobbyist, not understanding everything properly, decided to use this before, seeing not good performance, then seeing a warning message like that. Guess what I did? I left it. I was like, okay, fine. I'm not going to change it. I'm not going to fiddle around with it. That's not my zone. I can't do anything about it. What I'll do is I'll charge it for an hour. I'll practice for 15 minutes. Charge it for an hour, practice for 15 minutes. Wow. Do you see what happens when you don't have enough information? You do dumb things, right? To charge something for an hour so that you can only use it for 15 minutes and to keep doing that every day. I look like a moron. I was like, oh, this thing is down. Charge, wait. Check the total power, and it's like, oh, cool, it's fully charged. Drive for 15 minutes. Oh, shit, it's not working. Okay, charge. Seriously, I felt like I know I'm not supposed to swear, so I'm not going to swear. Let's move on. Someone suggested then saying that why don't you power the Raspberry Pi separately? There are a lot of power banks that you get. Connect a power bank into the car. Just power your Pi separately, completely. It's a 5 volt. I think the Pi needs 5 volt and 2 amp or 2.5 amp or something like that, right? So I was like, okay, cool. Started to try various different kind of battery packs. Went to the China mall, bought some Chinese brands and stuff. They say 5 volt, 2 amp, connected. Hold on. Pi is not booting up. Why? Because the freaking thing is only giving me 1 amp, not 2 amp. So please don't buy those things. Okay? It doesn't work. I wasted 3 of them thinking that, oh, maybe I need to buy a bigger size one. So bought a bigger size one, right? Now I can't fit it on the freaking car. It's like, okay, that will not work. Went back, changed it again. Finally, then someone suggested saying that, look, iStore is selling something. It's this brand, Anchor. Why don't you try it? It's like, okay, last resort, man. Let's just do it. Tried that. Works like a charm. Still booting it up right now. And, oh, look, all 4 blue lights are on inside. It's amazing. It's amazing how when you go and ask for help from smart people, and dumb people like me have to do that, they suggest you such good answers, but you don't listen. And that's my problem. I'll go and do some foolish things first, try to break it down, try to attempt everything from my side, okay, feeling like I'm the man, I'm the genius. Fail, and then it's like, hold on, what did he suggest? Okay, cool, that was something 2 weeks ago. Should have just done it then, man. Would have saved so much of time. Okay, cool, so now this thing just charges and boots up the Pi. Not the motor, not the servo, they literally take a lot of power. So I just left it to the special battery, which I again still charge for an hour and use it for 15 to 20 minutes. If anyone knows something else about it and says that, look, there's a better battery, please suggest me, because I really want to throw this thing out. I want to put the good one. I don't want to charge it for 1 hour and then use it for 15 minutes. Cool, this one was cool. After doing all these things and running around and stuff, finally ended up finding something called DonkeyCar. And guess what? DonkeyCar had all specifications, everything given. Would have saved me 2 months. Would have saved me 2 months just to read their information, instruction, and do exactly what they said. Because the smart people have already written good stuff there. But me being foolish, decided to do a lot of things myself for 2 months, trying to figure out everything myself, failing at a lot of places, and then finally ending up finding DonkeyCar. Their specifications were amazing. They gave all instruction sets, car. The only good thing and lucky thing that happened for me was I had the right chassis. That's it. That's it. All these previous slides and other things, a lot of people had already given comments about it. A lot of people have suggested a lot of good things about it. People, those who truly, really care about these things and worry about these things, and they are a pro. They know everything. Me, I don't. Finally ended up finding the details that, hey, in order to put something where there's a Raspberry Pi, a servo motor driver, a few other connections and everything like that, I need to have some sort of a roll cage built around here so that it can hold the camera also nicely, connect everything properly in there. And guess what? Whenever the car toppled and had a lot of bumps and this and that, this was the thing that really saved everything else. So finally ended up finding Okay, well, I did contact a couple of guys to say that, okay, can I print these parts now? Where do I print them? Started to go around finding proper 3D printing places and stuff. The materials are different. Shape sizes, the kind of details that you need are different, right? So this time I did the smart thing. I was like, nope, I'm just going to pick up the specification that DonkeyCar has given. I want exactly like this. I'm not going to put my creativity into it. Guess what? Did a good thing. It works. So basically what happens is that this thing, the roll cage has got two parts. One is, of course, the top cage. I'll go through the slides quickly, and then I've got a Zoom call through which I can show you the exact connections and everything. I hope that's okay. Cool. So it has got a top cage and has got a base plate. The top cage is, of course, has got a proper holder for your camera to be put over there. Connects very nicely. And then, of course, your base plate holds your Raspberry Pi, your servo driver, and anything else that you want to put on top of it. Has got proper cuttings and everything over there. Very nicely made, can fit properly. The most irritating things are the screws and the nuts and the bolts. They are so tiny, and I've got fat fingers. Okay? It doesn't work. It's very difficult. So let's try to assemble all these hard parts, right? And you'll see what I mean. So that's my workspace over there. Set up everything nicely. Had all the parts put over there. That's the freaking Chinese battery that didn't work. That's the one. I should have changed the image, sorry. Do you see? Foolish thing. Okay, so of course all the parts are over here. You can see the battery. I'm going to go from left to right. The battery, SD card, an adapter for the SD card, the camera connector, the camera itself, normal USB-C, USB 3 to the normal USB connection one, crappy Chinese battery over there, the servo motor driver, the Pi itself, a very faulty DC to DC voltage converter that I shouldn't have decided to use, and then some cables to connect certain pins. And of course, a lot of nuts, bolts, and screws and whatnot. Cool, let's start the hard work. These things are so tiny, I had to find another way of tightening them, screwing them up properly. Things were fine, started to arrange everything as they should have been put on the slate. So all those things are there now. I put the top cover also, started to look quite cool. The most difficult thing over here was to actually put the screws for these ones at the back and the front. When you 3D print something, it looks very nice and it's like, oh, this looks so nice. I'm just gonna put it over there and lock it. No, it doesn't. Because the inners for your normal bolts and your places where you need to connect it, those things are not printed the right way. So you have to then take something, cut it out, make sure that there's enough space for it to fit in properly, and then screw it tight. Cool. Connected the camera. All those things are fine. Started to look a bit good. I was like, yes, this looks nice now. I'm moving somewhere. Before I decide to do something stupid again, right? Let's see, what did I do this time? Oh, no, I didn't actually. Oh. Okay, cool. So decided that, look, I've used Raspberry Pi before. This is a different model from 2015. The pins are quite different. Before I just start to go and try and test these things, and a lot of my colleagues and friends have suggested saying that, look, the GPR pins are very sensitive, so be careful, otherwise you're going to damage it. So went to the Raspberry Pi website, downloaded all the specifications about the pins, understood a little bit, did a lot of reading around what kind of pins goes where, what happens where, and that's just an image over there that you can see how the servo driver is connected to the servo itself and to the electronic speed controller. And then these are the pin connections basically that happens. I literally went word to word as it was in the book. Seriously, that's it. And that's how the car looks now. Dope, eh? Cool. I was very happy. I thought like, yes, after 3.5 months of something, finally I've achieved something, okay? At least looks like the hardware is sorted out. But I didn't know that, you know what? Just having the hardware, just because I went and bought a BMW doesn't mean that, you know what, I can drive it very well. Maybe I'm not a good driver. So what do? I do some foolish things, right? I almost forgot about building a freaking car track. That I have to train it. I have to have something. Because as soon as the hardware was ready, I was just like, let's just see how I can drive it, start to look for a RC controller, and then see that if I can just maneuver it and drive it around. And then I was like, hold on, I'm supposed to teach it. So how do I teach it? I need to have a track. On the next slide, I'll show you all the dumb things that I did. So there are various ways of building the tracks, right? These are some of the good instructions that you can see. Most important thing personally from my side would be that make proper bright lines, clear pathways. Don't have something that doesn't make sense to actually identify the difference between the path and where the lines end. Second thing would be more around shapes don't matter. You can have any kind of shape that you want to build. The materials, they're very important. I thought that, hey, maybe using rope might be a good thing because I was tired of sticking duct tapes and taking it out. And then again sticking duct tapes and taking it out. Because that's how I was busy building my path. Every time I used to go home, build a nice good track with duct tapes and all these things, try, it didn't work out. Next day wife comes and is like, no, we can't have it over here, please take it out. Okay. Remove everything again. 2 days later, I'm again back over there, again putting things around over there. I was like, no, this is not going to work. I need to find a simple solution. What do? Go and buy a rope. That doesn't work. Please don't do it. This is coming from a dumb person who has done foolish things, suggesting a smart thing to you now. Okay? So I decided I'm going to use rope. So goes to builder warehouse, go and buy the right size rope, thinking that, hey, this is a wide angle camera, it can figure it out, you know? It's a rope, it can understand, that's the difference, and there's the difference, and I can just throw it around anywhere. There you go, I've got my mobile track now suddenly, right? I can put it anywhere, and then build any shapes, and then try to train it over there, and then just assume that it will work. Well, guess what, it doesn't. Then did few other things also with a couple of the buddies. This is from Emerentia. Went and built a very nice big path without even deciding or thinking, is this the right way of doing it? After building everything and that scratch and other things that you see on the top, deep down when we started, and I started to write a lot of code to train the model, that I realized that, hold on, this thing is capturing insane amount of noise. It's just picking up all the nice blue clouds, the trees, and not my track. That's why it doesn't know how to drive itself. Had a lot of problems. The security guard wasn't happy with us. Yeah, did a dumb thing. Finally, a bit better ones. Thanks to some of the good colleagues from DVT suggesting, saying that, hey, look, there are some big meeting rooms over here in the office. Why don't you use those ones? I was like, why didn't I think about it before? So decided to build some tracks over there, use some paper tapes and stuff. Those are my creativities. I wasn't trying to build any kind of specific shape, it just happened. Just looks a bit weird. Yeah, I'm looking at it from this angle, looks weird. Okay, anyways, these tracks were good. The cars actually trained it on these tracks nicely. It followed some of the good guidelines around having clear, bright lines, you know, having any sort of shape that you want, hence why the paper masking tape. And because it was in one of our meeting rooms, I could easily dim and brighten the lights, so I could change the intensity of light and check and test in different scenarios. Hold on, I got my sandbox now. So now I can play around with it. Cool. Then I hit with another problem where, how do I maneuver the car properly? Because after I read about DonkeyCar gives a lot of things around like web controllers and few other things, right? And using that, you can use the up arrow key, down arrow key, or your WASD keys, or IJKL, or you can configure it also as you want it, right? And to drive it around. But hold on, when you're playing Need for Speed, that works well. Not with a physical RC car, it doesn't. I was able to like literally just drive straight, and as I start to take the turns, it won't move properly. So I was like, no, this thing is not gonna work. I need something else to control it. Finally, I decided, cool, I'm gonna connect one of the PS3 controllers and see if it actually works or not. Well, that really did work. Okay, so the camera keeps taking information, which are just normal images, 120 by 160 pixel. And then, through your controllers and stuff, you just pass a normal HTTP call via a web server and feed all the information and say that, hey, look, you know what? This is a user input. Literally, you're just passing control information to say that steer left, steer right, here's the throttle, move forward, fast, that's it. That's all the information that you're sending, and those are the instructions that you're feeding in. What happens in your autopilot or in your training mode, basically, is you have to train your machine learning, so you have to train your model with enough information, enough data, which is just basic images, right? And the more images that you have, after doing a lot of readings and other things around machine learning and stuff, I think CNN, convolutional neural networks, are the best way of training when you have a lot of images. That's one of the things that I actually gathered. So I was like, hey, cool. How do I write this CNN? Okay, I'm gonna figure it out later on. Let me just try to maneuver the car properly, collect information, as much of clean information as I can collect, and then I will feed it to the neural network. Well, back then it wasn't Keras and TensorFlow. Back then it was all about Groovy and Java, so I wanted to integrate into deep learning for J. And then I'll come into the hurdles and the dumb things and the foolish things that I did using that framework, right? We'll come to that soon. So collect more information, which is just your images, for the entire track. Literally a 10 to 20 lap that you drive can easily collect 50 to 60,000 images on a Raspberry Pi. Now this one only has a 16 GB micro SD card that I used. And I didn't realize that the more data that you keep throwing into the Pi, right, it slows down. So that was one of the main reasons for my Raspberry Pi to keep crashing randomly, because it doesn't have that much of processing power. But I'm literally thinking that this is a turbojet engine. I was like, pump it, man, pump it, go, do it. Ended up crashing a couple of times. Then I realized that no, I need to make sure that I collect the right set of data, doing the right set of steering movement, throttle, have a very controlled environment so that at least the initial set of data is good. Once I've collected even just 10 to 20,000 images, not 50,000, not 60,000, so your number or your quantity of your data doesn't matter. The quality of your data does matter. But it also means that it needs to be of certain range, like you can't say that, look, I've done one lap and I think I'm the pro, this is the best data, here are 100 images, go learn yourself. It doesn't work that way either, which is what I tried. So I was like, cool, just do 2 laps. How many images? 500, perfect. Feed it to the model, start to look at it. Calculations are not right, things are not working fine. I'm like, what am I doing wrong? If I collect a lot of data, this thing crashes. If I collect less data, this thing doesn't learn. Like, come on, man. Clap it. I only had one piece, so couldn't do that. Then, after learning and reading more about it, people said that, no, look, do only 10 laps or 15 max, right? But make sure that it is accurate data. The initial set of data is so valuable. And that's when then I realized the value of data. And suddenly my respect for all the data scientists and everyone just went this high. And I was like, guys, salute to you, okay? Wow. To actually sit and stare at 50,000 images, I went nuts. I was like, what am I doing wrong? Write Python code to go edit the images and stuff also, but still doesn't want to work. Crop it from 120 by 160 to 69 by 160, thinking that maybe less data, only the path will be perfectly all right. Hold on, the light intensity is not right. So hence why that path that I cropped is useless. So you will see now why in machine learning and artificial intelligence journey, doesn't matter what we're building or how awesome stuff we're going to build other than just consuming services, okay? We need to just make sure that the data is good. Then what happens is that after your neural network trains everything, it feeds or returns back a steering value and a throttle value. So we'll see some of the examples where what the CNN does after going through certain convolutional layers and stuff, 5 of them, doing certain other awesome stuff, it feeds back just a steering value and the throttle value to say that, hey, look, I've analyzed all these images. This looks like a straight path. This looks like a right. This looks like a left. If there's any other shape, I don't know what it is. And it returns back a steering value and a throttle value. Those details then goes and updates. So that's the pulse width modulation PWM value that goes back to your motor controller, which then converts it into a normal signal and feeds it back to your servo and to your electronic, the speed controller, which goes back to your motor. And then all this data is saved into a JPEG file, which is again same 120 by 160, and there's a JSON file data also, which holds a couple of information. around who was maneuvering it. Was it an autopilot mode? Was it a user mode? What kind of angle was it? What kind of throttle it had? What timestamp was it taken on, right? Because remember, this is just a normal camera. If I switch it on right now, it will just start to take pictures. That's it. So that's basically the entire overall architecture of what happens from a learning point of view, from a taking picture point of view, from feeding that information to your model so that you can pre-train these models and stuff, and then give that information back to your car so that there's a bit of a autopilot mode enabled into it, and then it understands, hey, this is what I can do with it. Cool. Now let's jump into the software part of stuff. There it is. If you torture your data long enough, it will just confess. Like, I give up. Tell me what to do. I'll do it. I don't care. So of course, moving on to the software components, I decided to make use of some of the things that I've been reading about, just to give it a try. And then later on, as I again started to use it and things like that, then I realized that, hey, these things are actually quite awesome. I'm glad that I'm using these ones. So MICRONAUT being one of them. You can make use of Spring also. It's just that I was amazed to see the speed of MICRONAUT on a Raspberry Pi. Believe me, 2.2 seconds to boot up and run, and then just spawn up. And I was like, no, there might be a mistake, sorry. Control C, check again the logs. What happened over here? Again, started up literally less than a minute all the time. And have a Spring Boot application over there doing some sort of REST calls and things like that, right? Will take plus minus 10 to 11 minutes. So I'm not saying that Spring is bad or anything like that. It's just that on a Raspberry Pi environment, I think MICRONAUT is a good option, right? If you have much more stronger processing power, more memory, more space, and things like that, by all means, use anything, okay? Robo4j, it's quite cool what these guys have done, actually. So all these things are, of course, open source libraries, all of them. For Robo4j, the guys wrote a lot of code, and these are literally machine-level code, C++ portions of the code and things like that, which are very unique, very specific to certain set of hardwares, right? Because the shared objects that you generate has to run only on those kind of hardware and only on that kind of architecture. Underneath it, it makes use of Pi4j and wiring Pi. The JR-PyCam library that I was using was to actually hook up the camera straight into, so that it's just a normal call that you do, and then it starts to collect information. And then you just pass information saying that, like, hey, take a still image, takes a still image. And then you make it into a succession, then it becomes a video. That's it. So I didn't have to do a lot of heavy lifting on those kind of things. I wanted to make it as simple, as elegant, and as quick. The place where I really got stuck, and that's why the straight face over there, is on the deep learning 4J. I didn't understand how to write a good training model. Because when you read about a lot of CNNs and various set of neural networks and other things like that, you're like, oh, this looks simple. I can do it. And then you start to write, and then you start to see all the row column multiplications that comes, and a lot of deep level information that comes in. And then you realize how bad you are, and you're like, no, I can't do this. Okay, and that was one of the places where I actually wasted a lot of time trying to prove and find out a way of implementing something that I didn't understand or didn't have good knowledge about into a framework like Deep Learning 4J, and ended up bashing my head a couple of times. Failed model, didn't run, had a lot of problems. Finally, I put that one on side, and I was like, cool, let me just make use of something that is tried and tested, and there's a lot of support, right, available from the open source community, which is your Keras and TensorFlow. And again, DonkeyCar had a Python kit already built for it. So all that I had to do was write a small Python wrapper that gets called from my Groovy code and firing it into the Python call. That's it. So that's something that I was able to do it. This one, I left it to the big bosses. I was like, you handle it. Maybe one day I'll learn it. What is MICRONAUT? It's a JVM-based framework. It does a lot of awesome stuff. Everything that you can think, from dependency injection to annotation-based configuration to HTTP routing, load balancing. So everything and anything that your microservice-based frameworks like Spring Boot and MicroProfile and many others are there, right, that it does. MICRONAUT can do it easily also. And the only amazing thing that I see with MICRONAUT is how lightweight it is and how fast is it. So if you have like embedded systems and small circuits and things like that, MICRONAUT is something that you should consider. Not that now you should go back to your clients and stuff. It's like, look, enough of Spring. There's a new child in the market, okay? That's MICRONAUT, and we're going to implement this. Please don't do that. It supports Java, Groovy, Kotlin, has got a lot of support for a lot of other languages also. It has got a lot of cool features. Please do go and check on micronaut.io. It's quite interesting what the Groovy and Grails guys have actually written. I'm very impressed. Jumping onto the Robo4j. Oh yeah, so these guys did win the Duke's Choice Award in 2017, and they have a lot of awesome libraries that they have written. So if you look at the image over there, the most important thing is, of course, the core and the math. What I'm using in the code is the hardware, the RPi. So those are the APIs that I'm using from there. And it's quite weird that for a hardware component, it's so simple as just initializing a class, which what we'll look into some of the code. Literally initializing the class, passing a value, calling the setter method, and it's like, hey, just do the job. And I'm like, oh, that's it. Okay, I thought it's going to be like something much more crazy, you know? But they have actually taken and done a lot of heavy lifting in terms of the low-level programming for you. Hence why it makes it easy and simple to actually consume them, use them the way you want it. Let's move to the Keras. Keras is a high-level neural network API written in Python, runs on top of TensorFlow, runs on TensorFlow. It uses CNN, controls the autopilot for the car, and there are some instructions that are available already in the DonkeyCar channel on how to make use of it. What is a CNN? As far as I understand it, whenever you have a lot of images and things like that, it helps you understand them, tune them properly, make a sense out of it, and then let you do something with it, right? That's like literally the dumbest example or the dumbest way that I can make myself understand, and hence why I'm just sharing that with you. These are the list of images that I took from a lot of driving and testing and things. Those are the JSON files that it creates. So you can see that there's a timestamp, who was driving it, a user or something, what kind of image it was, just associates to the same image that it was there, and the throttle and an angle value associated to it. And your steering angle value always goes between -1, 0, and 1, somewhere in that range. Same thing with your throttle also, right? And then your controller, your servo controller then actually changes into the desired signal and then feeds it back to your motor and your servo and others. This is something that I found from the DonkeyCar code base after digging and trying to just figure out how does this whole CNN thing works. And I found out that this was a freaking 20 lines of code. This is what does training for the model, where it does 5 level of convolutional 2D linear checks and stuff. Then there's some sort of flattening, dense, and dropout, and dense, and again. Calculates the angle and the throttle out, feeds it to the model over here, and then returns back the value. And I was like, so this is what I was trying to figure out for the last 2 months using deep learning for J, which I still don't understand 100%. I'm being bluntly honest about this. So if anyone knows more about this thing, please after the session, bug me. I really want to know what and how it does. And if you know more about it, please share it with me, because this thing is bugging me like anything. I know Python syntax and other things, but I'm not that great with the whole machine learning part of stuff also in here. So that's something that I would really want to learn. TensorFlow, everyone knows, it's a machine learning framework from Google. Does a lot of awesome stuff. And it was so weird. While I'm struggling and trying to figure out all these things, 2 weeks or 3 weeks ago, Google launches the 2.0 preview version, where they have given full support for Keras and actually have built the entire Keras implementation using normal REST APIs and other things also in TensorFlow. I was like, come on. Could you not have done this thing like just 3 months ago? Maybe I would have just used that. That's it, right? No, but I'm glad that that didn't happen, because I went through all the foolish phases of my life, doing a lot of wrong things, trying to figure out a lot of things. Later on, then I realized that deep learning for J actually had certain limitations. TensorFlow has got certain limitations also, where it doesn't support the 32-bit systems yet, and hence why going for an option with deep learning for J was quite vital. But in order to use that, you need to understand why you are writing your model the way that you should, which is what this is. So once I can crack that, then I can crack how deep learning for J can be implemented and how I can train the models using that. One of the bad ideas to actually run your training of your model on a CPU, that too on a Dell. 20,000 images, when it went through, took 3.5 hours to process. At certain point, I started to feel as if the laptop was going to burn. So please don't do that. I've done the foolish act, you shouldn't. If you have a good GPU, or if you have got cloud subscriptions and stuff where you can make use of GPU-based processing for your images and stuff, please do so. Not on your CPU. Oh, cool. Let's look at the demo quickly. It has been too quiet. I'm just going to make it a bit noisy. It's doing self-driving. I'm not driving it. So it learned, it saw everything, figured out everything, and then it started to drive by itself. That feeling is amazing. So the laptop was that side, I was just recording it. One thing that I picked up was, at a lot of places where I was driving and taking curves and things like that, right? It wasn't just mimicking me exactly at the same spot. It learned, and whenever it has to do something, and at one of the stages I'll show you now, where it suddenly just decides to slow down by itself and does a move that I did like 5 tracks before, somewhere else, but not there. And I was just like, wow, I think it's right here, oh, check there. So it just slows down by itself suddenly and then decides, oh, this is not the right way, and then just takes a small right. I know the way I'm explaining maybe might be, but if you're there and you've done it, right, and then you see it behave and you're like, this is not how I trained you. After 5 laps, you're behaving like someone else, you know? Maybe you have built some sort of intelligence. Yeah, it's just gonna go round and round right now. So if you guys wanna watch the 5-minute video, you're most welcome. Cool. I don't know how I'm doing with the time. 3 more minutes. Wow. Okay, guys, I don't think I can show you all the code then right now, but if you do want to have a look at it, please, after the presentation, please come sit with me. I'm happy to show you. What will happen next in future? Well, before I jump onto that one, I hope that through all my foolish mistakes, dumb things, whatever I've learned, I hope that if I've shared all those things with you, you guys don't do that. Or if you feel that you're going to do that, please bug me. Maybe I can share some more knowledge on how to not to be a foolish person like me. My future goals is, of course, learning and understanding the Keras CNN better. So if anyone knows about it or anyone has got much more better understanding, please do share. I'm willing to learn. Found a way of how Keras CNN can be migrated into DL4J. Very good examples and other things over there. I want to replace and remove the Keras and TensorFlow implementation in future. Still integrate into deep learning for J and make it a full-on Java stack. In future, I want to look into more of object detection and object avoidance. Maybe one day we can dodge the taxis and the potholes. Please don't use and try to train on a CPU. It's a very bad idea. Something that I picked up just recently that the Amazon guys have done, they have taken the same concept of DonkeyCar and they have made something that looks like a Darth Vader's helmet, actually. I don't know, with an eye. That's every time when I look at it, it looks like that. I don't know what you guys see. But it has got a lot of processing cool stuff. One of the cool things is that it runs on Intel Atom processor. That just nails it. It's not a broadband-based chip, right? So it's already quite powerful. And all the settings and other things are amazing. And this recently, I think November last year, 2018, in Las Vegas, they did this reInvent thing, right? And the Deep Racer thing. You should have seen this thing move. Oh my goodness. This thing can freaking drive on any track. Why? Because it has the processing power. The only difference was they didn't make use of a CNN-based neural network over here. They made use of something else. I forgot about it now. But it's something where if it does something right, it gets a carrot. If it does something wrong, it gets a whack. So there is positive reinforcement learning. Someone said something there. Yeah, thank you. That's what they're making use of. So that's the neural network that they're making use of. A lot of references over here. Literally, this was crazy amount of learning, crazy amount of reading, a lot of hit and trials. I'm glad I did it. Now I have learned something better, and I think I've achieved that goal of picking up a challenge, learning something new, and building something that I wanted to. Cool.